Hey yo, this is Miss Eisencraft with Lesson 15, Practice Problems, Unit 4. Let's say that again. Unit 4, Lesson 15, Practice Problems, numbers uno, dos, tres, cuatro. Okay, here we go. Let's start with number 1. We're starting on page 250, by the way. Okay, this inverse function business, it's pretty simple, but can sometimes get a little bit confusing. Okay, Noah's cousin, we have Noah's cousin, and okay, let's talk about that. Noah's cousin, he is exactly 7 years younger than Noah. So we have Noah, hello Noah, and cousin. Okay, we're going to let Noah equal N and cousin equal C. Pretty easy. One person's 7 years older than the other. Okay, so the first thing is saying, okay, we're measuring in years. Write a function that defines the cousin's age as a function of Noah's age. Okay, whenever they say as a function of, that means they're going to use whatever follows that. This is going to be the input. So if we're going to use Noah's age as the input, in goes Noah's age, out comes the cousin's age. Okay, so who's older? Noah is older. So if we start with Noah's age and we want to land on the cousin's age, we're going to need to subtract 7. So let's write the function. If we start with Noah and we subtract 7, that equals the cousin. Or we could just say the cousin is N minus 7. Noah minus 7. Noah is the input. Cousin is the output. Ooh, okay. In and out, because you're calculating. Whatever you're calculating is the output. Okay. So when it says write the inverse of the function, we want to do the opposite. We want to say, well, what if we start with the cousin's age and we want to land at Noah's age? Okay. So you can think of either going backwards through the machine or having a different machine where we start with the cousin's age, the younger kid, right? The cousin. If the cousin's age goes in and we want Noah's age to be calculated based on the cousin's age, well, the cousin is younger, we're going to need to add 7. Or cousin plus 7 equals Noah. Or Noah equals cousin plus 7. All I'm doing here to here is writing the output on the right or the left, and sometimes that really confuses kids. But the output is usually isolated as like what you found as your final answer. And sometimes we write it on the right or the left. But the important thing is it's all by itself and it's what was calculated based on this input. Okie dokie. All right, let's keep going. So let's, on this one, on the first one, Noah is the input, cousin is the out. And on the second one, cousin is the input and Noah is the out. And you can also see that, right, as a function of, on the first one, Noah's age. Okay, number 2. Woo-hoo. Same prompt, but now we have this new letter, M. M is representing Noah's cousin's age in months. Okay, so M is the cousin's age, but this time we're measuring it in months versus the C that measured it in years. Okay, so let's just do some calculations, okay, without any like algebra. If Noah is 15, okay, let's kind of do those little tubes again. Okay, if Noah is 15, bloop, in goes 15. Okay, how old is this cousin? Well, we already figured that out. If we start with Noah, we subtract 7, and then we're going to get how old he is. But that's going to be in years, right? So we know he's going to be 8 years old. So, in goes the 8. Okay. Then we want to say, well, 8 years old, how old is that in months? So then we're going to multiply that by 12, because if you have years and you want to say, well, 8 years is how many months? Every year has 12 months. So then bloop, 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 you're going to start with 15 years, subtract 7 to figure out how many years old the cousin is, and then multiply that by 12. And you're going to get 96 months. That was fun. Okay. Let's do B. What if we start with Noah's cousin who's 132 months. So if you're going to put 132 months in there and you're trying to figure out how many years old Noah is, first thing is convert this to just how many years old the cousin is. So we'll divide by 12. That should be fun. Miss Eisencraft doesn't want to make a mistake. So that gives you 11. I kind of separated this time. I had a hard time separating it. And then that, okay, right? This is how many years old the cousin is. And then, remember, the cousin is younger. So then you're going to put that in there, and then you're going to add 7, because the cousin plus 7 equals Noah. And that will be 18 years old. Amazing. Okay. So we want to think about like these operations here. We started with 15, we subtracted 7, and we multiplied by 12. And this, when we started with the months, we divided by 12 and then added 7. So this 12 and 7, either multiply, divide, add, or subtract. They're like these inverse operations and also can create these inverse functions. So let's keep going. Let's try to write them using variables. Write a function that gives the age of Noah's cousin in months as a function of Noah's age in years. So let's think about what we did here. We started with Noah's age, okay? Let's call that n. Then we subtracted 7. Then after we got that answer, we multiplied by 12. So to make sure we multiply all this by 12, let's go boop, boop, times 12. You can put the 12 in front or the back. And what did that equal? That equaled the cousin's age in months, which was n. We're not going to do C. That was right here. We multiplied it by 12, and now that's the cousin's age in months. Okay? And again, you could put that answer over here, which, isn't that much different, but it looks a whole lot different to our brains sometimes. And the 12 can also be in front there, but you're going to multiply Noah minus 7. That'll be the cousin's age in years times 12. Then you'll get the cousin's age in months. Boom. Okay. D. It's a fun one, you guys. What about the inverse of this bad function? Okay. So the inverse is this guy. So if we start with months, right? How many months old the cousin is. Okay, if we start with months, what did we do? We started with months, and we're then going to divide by 12, and that will give us how many years old, okay, the cousin is. Then after we got that number, we put it into the other function, and we had to add back the 7 to get to Noah's age, because Noah's older. So how many months old the cousin was, we plug that in, divide by 12 to get how many years old the cousin is, right? Then add 7 back, boop, and that equals n, Noah's age. So much fun. And look at, you see the opposite? And on this one, the input is the cousin's age in months, and the output is Noah's age, what you're trying to calculate. Sorry. Out. And here the input is Noah's age, and the output is the cousin's age in months. All right. All right, number 3. Let's keep on going. Can you still see me? All right, sure. Each equation represents a function. For each, find the inverse. All right, so all you have to do, this will remind you of some middle school math, right? If C equals W plus 3, then what does W, then what is the inverse, right? All you have to do is get W alone. You've done this before. So you can say, well, then W equals C minus 3. So that is the inverse. Of that first function. Okay, next one. If we have y equals x minus 2, well, then that would mean that y plus 2 equals x, or x is equal to y plus 2. That is the inverse of this one. Okay, let's try C. That was A, B. Let's try C. If y equals 5 times x, the inverse of that is y divided by 5 equals x, or x equals y divided by 5. I'm just writing the x on the left, changing your input and your output. And D, W equals D divided by 7. What is the inverse of that? Well, if you multiply by 7, that would mean 7 times W equals D, or D equals 7 times W. The inverse function. Good times. That was A. And that was B. Last problem. Sorry it's taking so long. Number 4. Okay, this is a good one. I'm going to write like a little table here. It says, the number of years, y, is a function of the number of months, m. So we're going to go like this. Years is a function of the number of months. So when they say it's a function of, we're going to use months as our input. Okay? Then it says the number, oh my gosh. Then it says also the number of months, right, is also a function of the number of years. Meaning you can convert one way or the other. So let's just go from months to years. Let's make it easy on ourselves, okay? If you had 12 months, you have a year. If you have 24 months, you have 2 years. 36 months, 3 years. 48 months, 4 years, okay? And if you go the other way, if you have 1 year, you have 12 months. If you have 2 years, you have 24 months. If you have 3 years, you have 36 months. If you have 4 years, you have 48 months. Okay? Ooh, looks like we just switched those inputs and outputs. Okay? Not too hard, but let's go ahead and write the equations. So when you write the equation, if you write the years as a function of months, okay, the years, right, to get years, you take the months and you divide by 12, right? We're dividing by 12. We're dividing this by 12. What are we doing to months to get to years? We're dividing by 12, dividing by 12. Years equals however many months you've had divided by 12. That would be how many years you've had. Okay? The other way over here, to figure out months, you take how many years you're at and you multiply it by 12. To get here, the input, you took 1 and you multiplied it by 12, multiplied it by 12, multiplied it by 12. What did you do to your input to get to your output? You multiplied it by 12. Here, your input was months, so you divided it by 12 to calculate years. I mean, so easy, it can kind of be confusing. All right. B, explain why the two functions are inverses. Well, because your input is becoming your output, right? And your output is becoming your input, and you have like this inverse operation and an inverse function. That is it. All right. And scene.